So today we will discuss about queue data structure. Okay. So last time we discussed stacks, and queue is a similar data structure, which is a logical data structure. We can implement queues using arrays. We will look into this, and also linked list. So in queue, we have a different priority. That means we have first in, first out priority. So we call this FIFO. So this is similar to normal queue. So we have queues in many places. Okay. So when you serve a queue, so the first person is served first. Okay. So when this first person is served, then this one gets the priority. So similarly, you have the same scenario or same priority in a computer queue data structure. So here also we will see how to do this. And so we have to have two indexes, two places to know, because so when we have a queue, so we have to know the front of the queue, because otherwise we cannot serve, and the people coming in should know the rear of the queue. If we don't know the rear of the queue, the people will come and join somewhere here. So we want to have two variables. One is front and the other one is rear. So when you have an empty queue, so we have both pointing to same place. Okay, so we can implement this in several ways, and we have to have size and the capacity of the queue, okay, as well. So we have to know these variables, and then when you insert one, okay, so we have to move the rear of the queue to this one, because so this is the first element, and we are so this is the first first served. So we will serve this one first when we are taking out someone from the queue, and then the rear will move here, and then we insert someone, and then the rear can move here, and then we insert someone, the rear will move here, and then when we're taking out someone, so we take this out to serve, and the front of the queue we have to change to this one, and then if someone comes again, so we move this here. So this is how we will serve a queue. Okay, so then there's a problem here, not like stacks. Stacks we insert and remove from the same place, because last in, first out. So we want to remember the last element only. But here, because the inserting position and the taking out position will be the same. But here it is different. When the problem comes, so you can have a scenario like this. Okay, the front is here and the rear is here. Okay, so you can remove somebody from the front, and the front will move here. Okay, so this is empty now, and then we can insert something here, and now it is So the rear will move here. The problem is now the list is, we have come to the end of the queue, but the problem is still it is not full because we have empty elements here. So how do you get rid of this one? So what we have to do is, so when you come here, we have to move this rear to here. Then only we can start inserting. So we will insert in a different color and like that. So when the queue is, the queue becomes full when we have inserted or when we have filled all the elements in the queue like this. Okay, so now you can have a rear here and front here. Okay, so it can be different. So then the front will move, and after removing this one, the next element of the queue is here. So the front also should come here. So it's going like a circle. Okay, so it's a circular queue. You can say it's a circular queue because you can, when the front goes here and then come here and goes here, likewise you can do. So how do you do this now? Okay, so we will try to implement this, and we need maybe 4 variables and then the array data section. So we need to have several variables or several variables in our queue class. So this is a little bit different than doing the stack. Stack, it was a little bit easy, but here we have to have different cases, okay, different scenarios. So we have to address them in the queue. So now we will implement the queue class in C++. So we need to create a class called queue, Q-U-E, and here we need to have private member functions. So we have to have rear variable, we need to have front variable, we need to have size, and we need to have capacity, and then we need to have pointer variable for data, and then we have public section and the constructor. So rear will be starting with 0, front will be starting with 0. So what else? Size. So what is the value of size? So it's empty, the size is 0, and we have to pass the capacity. So we will pass it in the here when we create the queue. Okay, and then we have to create data, new integer, and the size is capacity. So this is our constructor for the queue. And then now we will create the inserting and deleting from the queue. So we have a different name. So in stack we had push and pop, but here we will use a different terminology. So we use enqueue for inserting to the queue. Okay, so we have to check whether the first queue is full or not. So how do you check? So we have size, which is the number of elements. Size is equal to capacity. That means if this is the case, the list is full, so we have to print queue is full. Okay, else we can insert to the queue, we can enqueue the elements. Okay, So we have to insert from the rear of the queue. We have to insert from the rear of the queue. So we will insert, so rear is 0 now, equals value. So now we have to increase rear equals rear plus 1. And we have to increase size also by 1. Okay. So now we have a small issue here. The issue is, so when we have this, so we discussed this earlier. So our rear of the queue, so we start with here, go here, we go here. So this is our rear index, and we come here, and after that, so always we did rear equals rear plus 1. But when you do it here, so now it is 0, and this is capacity minus 1. Okay, the last element is n minus 1. So now it becomes capacity. So when you do this, when you insert something here, and when you do this, it will become, the rear index will become capacity. But actually what we want to do is, we want to take it here. So how do you do this? To do that, we can use modulus operator. So if rear equals capacity, so what we want to do is capacity, we want to make rear equals 0. Okay, so it becomes capacity. We can do it like this, but we can do it efficiently using an arithmetic operation. So how can you do it? So we can use this rear operation, rear plus 1. So this is the same operation, but we modulus it in capacity. So what will happen here? So when it becomes 0 and it will become 1, modulus will be 1, modulus is 2, modulus 3, modulus 4, modulus 5, and modulus n minus 1. And here it will become capacity, modulus capacity is, so this will become 0. So it will come here. So we will use this operation, this condition for our program. So we will have something like that, and then we become modulus capacity. Okay. So now we are fine, and now we have to do the DQ. So the removing from the queue is called DQ, and here we have to check the size is, the queue is empty. So if the queue is empty, size is 0. So if the size is 0, we cannot increase. Okay, so we will remember the temp, the front of the queue, using a temporary variable, because we are using, moving the front variable. So again, front should be front, we have to move front by 1, and here also we have to use the modulus operator to make it circular. And then size should be decreased by 1, and then we return 10. Okay, so sorry. Actually, it should come in the else condition. So if the list is not, queue is not empty, we have to do this. Okay, if the queue is empty, what we will do, we will see out, standard see out, and we can say queue is empty. And now we have to return something. Okay, so we will return uh, invalid. So if we return some value, we don't know whether it is invalid or not. So we will return the minimum integer position, the minimum value we can take in that integer value. To get that value, so we have to use another library. We have to get a library called limits, and then we can return int min. So you can type and see what is the integer minimum. So this is the minimum of the integer value. So we can say that all the values in the queue is greater than this. So if something, some point, if we return some integer minimum, we know that this is this is we didn't return a valid value, or we can use pointers. We can return a null pointer or something like that as well. But here we will use this method. And now we want to create a method to print our queue. So how do we do this? Because now the values are circular. So we don't know, we know the starting point and ending point. So how do you do this? We can use a for loop here. So integer I equals 0, I less than size, because we know the number of elements, fortunately. Otherwise, it will be difficult. And we have to start with the, say, front of the queue. So start with the front. So int index equals front. So we will print front first. So if the size is greater than 0, it will go into the loop. So we print std cout data front or index in this case, and a space, and then at the end I will print a new line character as well. So now we have to increase the index by 1. Index equals, go to the next value, and here also we have to use the modulus operator to go round, go in circle. So now we will create a queue, say with 5 elements. So now enqueue 3, queue enqueue 5, queue enqueue 4, or say 12, queue enqueue 45, and queue print, and we will run this. Hopefully no errors. Okay. So the front of the queue is 3, 5, 12, 45. And now we will enqueue, dequeue some values. Sorry. 2 values maybe. And print it, the queue. Okay, so now we have removed the first 2 elements, and now the queue starting point is 12. And now we will insert some other values again. So we have 2 values, so we will insert, say, big values. Okay, sorry. So now, So you can see we had this queue is full message because we had two elements and we insert 1, 2, 3. Now queue is full, and then if we insert 34, now we cannot insert because we had only 5 elements here. So queue is full. So now when we print the queue, you can see the first element is 12, 45. So 3 is 45, 3, 46. This one is the last element. So now we have implemented the queue using an array. So next time we will see how to implement a queue using a linked list. Now we will discuss how to implement a queue using a linked list. So in a linked list we have something like this. Okay, and we can have a pointer to the head node and the tail node. Okay, so we can use this to represent a queue. So this is the front of the queue and this is the rear of the queue. So if we want to insert a new element, we have to insert it at the end of the queue. So how do you do it? So we have a temp pointer and then we put this here and we put this one here. This is null. And when we remove this one, so we put a temp pointer to save this one and then move this one here, and then we can delete this later. So it's very easy to implement a queue using a linked list, and the difference here is we don't have a fixed size. Okay, so we don't need a size variable, capacity or anything. So we just, as long as we have memory in the computer, we can create the linked list. Okay, so now we will see how to do this using C++. So I will use the same class, and here we need to have a structure node, say Q node or something like that. You can have any name, and here we need to have value and a pointer. Next, and we can have a constructor, and so here equals v and next equals null. Okay, and now we can we need two variables here, private variables. So we need a Q node pointer to the head of the queue and Q node pointer to the tail of the queue, and then that's all, and we can have a constructor. So here head equals null and tail equals null. Now we can implement the enqueue and dequeue operation. So void enqueue. So we pass a value. Okay. And then we can have dequeue and returning a value. Okay. So now we will start doing this. So first we have to check, we have to create a new node. So we'll say temp equals new q node and pass the value. And then what we will do is we have to check the list is empty or the queue is empty. So how do you do it? So if the empty queue or in linked list, we have two cases. Empty, when we are inserting to an empty list, we have to, because since we have two pointers, head and tail, we have to change both. And if we are inserting to a already non-empty list, we have to change only one pointer. Okay, so we can check, since we are inserting rear, if rear is null, we can say head equals temp and tail, so here equals temp. So this is actually, we are using tail as the pointer. Else, what we will do? So rear or tail, next is our temp variable. So from the current tail we go to the temp, and then we have to change the last pointer to the temp. Okay, and DQ also we have to have we have returning from front equals null. So we can print something not front, so head, actually we are using head here, and if the head pointer equals null, which is empty, so if we want, you can print something it was empty or something, just return. Else we have to have a q node pointer temp equals head, because we are going to change the head to the next head, next element, head equals head next. Okay, so then int val equals temp value, and then you have to delete temp, otherwise there will be a memory leak, and then return. Okay, and then we have to write the print function. So here void print. Okay, so here we have to have a pointer current equals starting with head, while, so we have done this, current not equals to null, we will print std cout current value, and then a space maybe, and then we want to move the current to the next node, current equals, so we have done all this in linked list lecture, and finally we may need a new line character at the end. Okay, so we have done it, and here we don't need a class size. Okay, everything is fine. Now we will see whether we get the same result. Hopefully, there's an error. Okay. Okay, here also return. So we will return the limit here, the minimum, same integer, limits. So here we will return min integer min value. Okay, so now it should be fine. It should work well. Okay. So we return. Okay, now it's different. So we have 3. So we will go here because the list never get full. So 3, 5, 12, 45. Remove first 2 elements and then the queue will look like this. And then again we insert 335, 346, 447 and 34. Earlier this 34 was not included because the size was full, but now you can see it is included. So here you can see the difference between the previous implementation using arrays and the current implementation using linked list. So we have discussed the basic operations using queues. So you can use these queues in algorithms like, for example, print queues and most of the programming algorithms. So we will discuss them later, how to use these in algorithms. So now in this lecture we will only discuss the basic operations of queue and the implementation.